and welcome to session 1 of the 2021 GCTC Agriculture and Rural Supercluster Workshop. Special thanks to Purdue University and the Purdue Research Foundation for hosting and actually for Troy and the whole crew that set this thing up, because I know, especially with this sort of combination of remote and in-person, it gets to be much more complex. But I think this is where we are in today's world. So it's a technology has saved us in this sense. Thank you to Dean Engel from the College of Agriculture and Dean Chang for your earlier welcome. I almost felt like we already had a session 1.A or something for the earlier discussions for your earlier welcome. And thank you to West Lafayette Mayor John Dennis. I'll just do a personal note, which is different from my 6 other introductions, that my brother Frank and I actually feel right at home since we both grew up in West Lafayette. And we both have degrees from engineering and agriculture. So the two of us, and he also works for the federal government, he works for the Navy. So we call ourselves guns and butter. One of us is always prospering within the federal government. And so, but that's what we call ourselves, guns and butter, and our discussions are trading federal acronyms at the dinner table. We have the same acronyms, just different meanings. So you have to be careful what you say. We will look at 3 topics: broadband needs of agriculture, what is or agriculture technology, and the workforce impact. These topics are swirling with accelerating dynamics. The goal here is to tie the topics together, and you already heard some of that earlier about this tying different silos, I guess, together. If you're in broadband, if you're in ag technology, or AKA precision agriculture, or if you are hiring or in the workforce in the farm and rural sector, here's a chance to hear a discussion of the integrated whole, which I think the dean earlier was talking about. So we have 3 great experts joining us today. I will introduce the 3 and then we will get going. Chris Ali is Associate Professor of Media Studies at the University of Virginia. His current research focuses on broadband policy and deployment in the United States, specifically rural area. His forthcoming book, Farm Fresh Broadband, The Politics of Rural Connectivity, examines the complicated terrain of rural broadband policy in the US, and Chris is right here. Our second speaker will be Dennis Buckmaster, Professor of Agricultural and Biological Engineering at Purdue. He previously served as Assistant Dean and Associate Director of Academic Programs in the Purdue College of Agriculture. He is a Dean's Fellow for Digital Agriculture. And most importantly, from my standpoint, he is an organizing member of the Ag and Rural Supercluster that organized this workshop. I picked this out of your bio. He is a master of phrases, and I have to read this because otherwise, so you don't have to read it. So from his mini autobiography, it says, "You may never know where I'm going, but at least you know where I'm coming from." And I think it's appropriate. Our third speaker, who will be joining us remotely, hopefully Aaron can hear us. Aaron Magenheim is the CEO of AgTech Insight. Aaron is an entrepreneur who grew up in California agriculture and has been a global industry leader working across the agriculture and technology nexus. As CEO and co-founder, his companies AgTech Insight and Growers Insight specialize in strategy and implementation, farm innovation planning, and building successful ecosystems, leveraging technology and best practices throughout the agri-food chain. So let's begin, and I think we'll start with Chris, and I'll turn it over to you. And remember, each of you have 20 minutes, and I will try to enforce that. And I'll give you the high sign or cut you off, and then we'll continue.
Really great to be here, and really great for my first in-person presentation, conversation in so many months. So really excited to be here. One of the reasons why we thought it would be a good idea for me to start off this panel is so that we can lay a little bit of groundwork about broadband in general. I'm going to, and then I'll talk a little bit more specifically about broadband on the farm. And I apologize if this is redundant for some of us, but I just want to make sure that we're all kind of on the same page. As Robert says, I'm the author of the little plug for my book, forthcoming book in September 2021, Farm Fresh Broadband, The Politics of Rural Connectivity with MIT Press. So I originally thought we had 10 minutes, now we've got 20, which is great because we all know that, you know, you give an academic a minute and they'll take an hour. Want to talk about broadband, want to talk about broadband to the farm, want to talk about broadband on the farm, and then a couple of policy challenges that we're facing right now, one particularly about mapping, surprise, surprise, we don't know what broadband is, and some of the policy responses that have come down the pipelines in the past few months. So just as a basic definition, when we come to policy, we define broadband, or at least the Federal Communications Commission defines broadband as an always-on connection of 25 megabits per second download, 3 megabits per second upload. This is something, you know, hopefully a lot of us here in this room will be familiar with, but for those who don't, this is our definition. Multiple problems with this definition. First and foremost, it's outdated, right? It was set in 2015, does not capture current or future usage. Last time I checked, the current average speed in the United States is 192 down, 68 up. Large policy conversation towards pushing for 100 symmetric definition of broadband, which would really force providers to upgrade all of their networks. And it would by definition not include kind of outdated technologies like geosynchronous satellite or DSL provision. That, however, is a massive political fight trying to get 100. And if anyone has just recently read the new broadband package of the broadband component of the infrastructure package from the Senate, you'll see that broadband is defined at 120, mainly because of the cable lobby. The other problem with this definition, and this is where it becomes particularly important for growers and farmers, is that the definition is asymmetric, right? It's privileging download over upload. And what that also means is that it's privileging consumption over production, right? We might be able to stream Netflix super quickly, but we're going to have more troubles uploading things. And when we're talking about data, we already heard one of our presenters here talk about the terabytes of data that need to be uploaded. Talk about broadband on the farm. So we really need to be thinking about that upload component, that production component of connectivity. Couple of figures just to get us started off for the day when we speak about broadband to the farm. According to USDA, only 75% of American farms have a computer with an internet connection. But of course, not all internet connections are considered equal. 3% of American farmers still have dial-up. 3%. 22% use DSL, 16% cable, 12% fiber, 18% mobile, 26% satellite, and 3% unknown. This is tremendous. It is a clear indication of the lack of connectivity and the lack of, or the most underconnected connectivity, underserved of American farms. 60,000 farms still use dial-up. 60,000. That's bananas, right? A technology from 1995. 60,000 farms. There's more bad news if we look at reports from the United Soybean Board. 60% of farmers in their 2019 poll or survey say that their internet connections are inadequate to run their business. 78% of farmers do not have a choice in broadband provider. Only 40% have a fixed connection at all. And 37% want to increase their use of data in their business options. And according to the United Soybean Board, fast, reliable connectivity will be the linchpin in the America farmers' future success. One of the things I really wanted to focus on in my 20 minutes, and I admittedly have no idea already how long I've been speaking, is when we speak about broadband on the farm, we need to kind of dial back a little bit of the hype that's surrounding fiber optic communication. We hear about fiber optics as future-proof and as the gold standard. If anyone read President Biden's announcement on the American Jobs Plan, right, he said that broadband should be future-proof. Well, that is code for fiber. Right? Fiber is gold standard. Fiber is what is going to get us into the next decades of connectivity. But fiber to the farm only gets you to the house to the barn, right? You need an edifice. You cannot have combines running around with cords connecting them. So for the rest of the farm, we need wireless. Right? And that's going to mean that the conversation we're having about fiber, especially when we talk about this new infrastructure package, is going to have to balance the need for the future-proof fiber with the technological need of specific communities, right? And specifically for ag, this means high-capacity wireless with a fiber optic backhaul. Just a quote from John Deere, who's kind of been talking about this for the better part of a decade now. If it works the land, it needs mobile broadband. Another one of my favorite quotes, and it's always fun to bring Taylor Swift into a conversation about broadband to the farm. This is from the Association of Equipment Manufacturers. When you consider that a typical cornfield has about 32,000 plants, that means that every cornfield is producing about 32 megabytes of data annually, or about as much bandwidth as it will take you to stream the first 4 singles off Taylor Swift's new album. But with 450 million acres of corn in the United States, this means that farmers are already producing 14.4 million gigabytes of data related to their corn crops annually, nearly 10 times as much bandwidth as has been used to stream Taylor Swift's latest single 205 million times this year on Spotify, and that was from 2017. Right, so what does Taylor Swift have to do with broadband to the farm? It turns out everything. Just her and her cartoons. So what this means is that this is a lot of data we're talking about, and a lot of data requires high performance broadband, to use a line from my colleague John Sallet, and not just good enough broadband. So what does it mean? What does this mean for options when we talk about broadband to the farm for wireless options? We certainly have a fixed wireless option of fiber to a tower that will then use radio waves to transmit. We can have mobile. Sorry, I'm just going to move. I can just move it over here. Okay, yeah. Mobile, but the problem here is that rural communities barely have 5G. And it was discovered in 2019 that big telco had overestimated or over-exaggerated their 4G deployment by 40%. 40%. So when we see those maps of those, big pink maps of T-Mobile or the blue maps of AT&T, right, those are exaggerated by upwards of 40%. Right, and when we think about 5G, a lot of it is existing if we're looking at T-Mobile's rollout only on low-band frequencies. But just the other day, acting chairwoman Jessica Rosenroth announced a new push for mid-band 5G. Then, of course, we get to satellite. Elon Musk recently said that he wants 100% of the United States of rural and remote areas to be covered by at least 25.3. But we've also, we also know from years of experience that geosynchronous satellites, such as provided by Viasat and Houston, is subpar. If anyone has ever tried to send an email using satellite, broadband, you know exactly what I'm talking about. So the options aren't great, and this is where we really need to think about a concerted policy effort to push for wireless options for farm. Of course, the other major thing that we need to be thinking about and talking about, and it's great to hear that Indiana is thinking about broadband mapping, is that we actually don't know who has broadband and who doesn't in this country. One of the major problems is that, of course, we only map broadband to the edifice, not to the field. For those of you who don't know this kind of current controversy around broadband mapping, the Federal Communications Commission collects broadband mapping data by something called Form 477, which has become rather infamous in broadband policy conversations. And what ISPs have to do is they have to report broadband deployment by the census block. So long as one building within a census block is served, the entire census block is considered 100% served with broadband, which means that the Federal Communications Commission has drastically and dramatically and spectacularly overestimated the number of connected Americans. Some studies suggest upwards by 50%. Right, and if we think about farming, if we think about precision ag, if the house, let's say, has an internet connection, we don't know what's going on in the field. We don't know if there are wireless options going on there. And that's part of the problem, which means that farms are also being overcounted, right? Because we're not counting farmland. So John Deere has actually suggested that the FCC start counting modems on a farm rather than houses or edifices with computers, right? So if we count modems with new technologies, every device or every piece of equipment now has a modem, we can start to get a better indication of connectivity on American farmland. A couple of policy and politics points to leave us off with here. USDA Reconnect grant, of course, gives more points to providers who promise to connect farms. That's great. The FCC Precision Agriculture Task Force was ordered by the 2018 Farm Bill. Did not see a whole lot of action coming from them, but they've recently been reorganized and re-energized. They're mandated with developing policy recommendations to promote the rapid expanded deployment of broadband on unserved agricultural land. They have a goal of 25% or 95%, excuse me, connectivity by 2025. See how that works. They are recommending geographic build-out requirements rather than population-based requirements, again, to take into account the massive amounts of fields and farmland. Just the other day, the National Science Foundation, in conjunction with USDA, announced a new rural broadband test bed in Ames, Iowa. And the aim here is to maximize wireless technologies for agriculture. And then lastly, we've got the American Connection Broadband Coalition, a coalition of private businesses led by Land O'Lakes to advocate for wireless options. So a couple of options coming down the pipes, which is going to be exciting to see. A couple of recommendations that we can think about and maybe have a conversation in the question and answer. Do we need to think about set aside funding for broadband to the farm? So far, we don't have that, or we don't have any earmarks for broadband to the farm. In policy, it does not exist at specifically in either the USDA or the FCC funding programs. It also hasn't been talked about as part of the, or at least hasn't been announced as part of any CARES Act or American Rescue Plan, specifically about broadband to the farm. Do we need to change the way we map broadband to include farm land and supporting buildings? At John Deere, this is something that has been John's talking points since about 2012, actually. We need to think about fiber middle mile expansion to rural areas for adequate backhaul. This is something that was also recommended by the Precision Agriculture Task Force. The FCC needs to change policies regarding state funding and USDA funding. I'll just give you an example. In the Rural Digital Opportunity Fund, the FCC's recent $20.4 billion fund, if you are an entity that has received money from USDA or from your state, you are ineligible for FCC support in this recent round of funding. That really kind of cuts the legs out from under a lot of providers who have received state funding or USDA funding. And then, of course, the big thing that we could talk about until the cows come home is interagency cooperation. There is not a lot of interagency cooperation between the FCC, USDA, and NTIA. This is despite a 2014 memorandum of understanding between the agency and, of course, the Interagency Cooperation Act that was part of the Consolidated Appropriations. So a couple of things that maybe we can all talk about as a group, or a couple of things to mull over as we go back to our home institutions. I want to lead us off with a quote from a colleague of mine who I interviewed for my book, Bernadine Johnson of the Landon Foundation. And she just has this beautiful line. She said, "Everything is better with better broadband." And I just love it. I love being able to end presentations this way because it really makes us think about not only how life can be better, how our everyday lives can be better with broadband. And we certainly learned about that during the pandemic, but how other industries, agriculture in particular for our purposes here, can be better with better broadband. So thank you very much from both me and my research assistant, my hound dog Tuna. I'm really looking forward to this conversation today. I'm not an engineer, so I can't speak about the technicalities of addressing latency in terms of architecture for broadband. But at the policy conversation, which is something that I can speak to, I do think that we have become absolutely fixated by the speed conversation. And I think it's because we're looking for ways to reduce a very technical, very technological conversation to a couple of things. When I'm thinking about latency, the ones who are particularly bringing it up, and this is where lobbying also comes as well, is that satellite companies do not want us talking about latency, and they have lobbied hard to remove any conversations of latency from FCC conversations, because if we start talking about latency, satellite cannot possibly compete, right? And if you look at, just the other day, Common Cause released a report on the 10 largest telecommunications companies who are lobbying Congress. Viasat is within those 10. So Viasat has been tremendously aggressive in stopping or at least stymieing this latency conversation at the policy level. But I do agree it's a conversation that we need to be having when we think about a more holistic environment for broadband policy.
Okay, Thank you.
So I repurposed a couple of slides, and if you watched the Broadband USA, there was an NTIA thing earlier in last year, I think. I repurposed a couple of slides, and I won't speak to these because you can read, and I have some logos there. And so my comment about these first two slides are, these are existing, commercial. People are making money doing these things. So this is the impact on agriculture already. Of course, it is not exhaustive. I tried to just come up with some samples of some companies that you know, you've heard, you know of them, maybe a couple of them that you haven't, so that maybe you can Google it and find out about those things. All right, so these are commercial examples of making an impact in agriculture today, last year, and of course, next year and the years to come. And I'm talking a little bit just so you can digest the slide. Of course, these will also be available to you later. Some of these do require broadband connectivity in order to happen. Some of them don't. Like delayed analysis of data to make strategic decisions is often okay. But when it's a logistics issue, what am I doing in the moment or today? Well, then those are like turning things on and turning things off, anything autonomous. Well, then you need a high capacity connectivity. So here's just the second slide of commercial examples today. So as you're looking at those, can you sort out, well, which ones of those do need low latency, high capacity bandwidth up and down, or up or down, one or the other, or maybe both. And so you see quite a range there. But some of these relate to autonomy. So it's a very critical issue. So I just want you to have access to those, some samples from existing. Now I really want to shift to a little bit of more futuristic thinking and spend a little bit more of my time there. So you'll have this slide, you can go read this thing. Here's the shameless plug. A colleague, Ankita Raturi, just came to Purdue within the last couple of years. She is an informatics professor from California originally. Well, her degree's from there. She's from Fiji. I want to go meet her parents at their home someday. This was an invited paper, and she very much took the lead. We did it together, but a couple of the elements of this paper were her thinking. And what they were is what we call design fiction. Design fiction. So what I'm about to show you are certainly things that we could do today, but we haven't implemented yet because it's darn complicated. But I want to set forth in the next few slides. There are actually only 3 slides, but I have a lot of animation, so I can just show you a piece at a time. I want to help you get a vision for what could digital and data science, artificial intelligence, and connectivity do to improve certainly the life and the decision-making of the farmer, but also improve the environment, to improve the traceability of all the things that we produce from the land, etc. So you've just read that. Now you're familiar with Valley Farms. So remember, this is it fiction or nonfiction? True or not true? Not necessarily true, but certainly could be. All right. So I'm going to walk through many of these, and Robert, if I get going too long, you just have to speed me up. First one, put on your VR glasses, and I'll show you some anomalies in your fields that they're all tagged from the UAV imagery. Wouldn't that be slick? It's just 10% early, but by means of you're going to do machinery maintenance, and it's a little bit early. But if you do it today, because it's going to be raining, or it was raining, and Thursday and Friday, you can't go to the field. So do the maintenance just a wee bit early, and then you won't have to do it on the holiday weekend. Now, this is the sort of thing that a person can manage and think about. But we're too busy doing work sometimes to think about these things. But if our data flowed and there was a super engine, I'm just trying to explore your possibilities. Optimal spray rates with maximum benefits require high quality image data within the next few days. I suggest the AI system, Siri or Alexa, is saying, send UAVs to these 3 fields today because they had excessive weed pressure last year. So you're prioritizing the work because you can't get all of the work done. So you do the most important work. The latest tillage passes through your fields have been analyzed and your line needs have been tallied. Would you like to spend down some of this year's profits to treat the fields that could wait until next year? Those of you that know anything about liming, it's a long-term thing. You could wait until next year, but if you spend down this year's profits, well, then probably going to do some tax savings. And the My Fields app is prioritized by the yield impact, which fields, and you can press a button and order your lime automatically. You have 63% of your land planted, and because of the recent weather, you may have labor capacity to check your inventories to be sure that the projections are right and get you through the end of the season. Last year, Jack and Jill did that. You want to have them do that tomorrow. The planter and sprayer parts are tallied in Trello, your board. Consider having Julio take one of the farm trucks home this evening so he can get those items on his way to the office tomorrow. The dealership site shows these in stock and the store is only 3 miles from his home. All right, so I want to pause on that one for a moment. Do you realize now that the dealer's inventory needs to be accessible? Well, we're used to that. I can shop at Menards, Real King, Walmart, and I can know before I go, is it there? I can put it in a shopping cart and get it. So this is the same sort of thing, but also merged with your local data. Like these are the things you're going to need because of regular maintenance or wear, right? So that requires connectivity. Now that's not high speed connectivity. Like you can send those sorts of data elements pretty cheaply, but it's connectivity evidence. According to the Context app, which is tracking your season's progress, 555 acres of the Hill and Vale farms have yet to be planted. Hill and Vale is over there. According to last week's actual field capacities, we've been tracking your machines and you're covering so many acres an hour. You can take advantage of the recent weather pattern, move all of your equipment over to Hill and Vale and get that neighborhood done next week. In the plot plans, if you choose to do that, the plot plans in My Fields, the app, will generate the load list for all your seeds and chemicals. Right? What data went into making that happen? Soil, weather, what was your cropping plan? How has your machinery been performing? How far along are you in the work of your season? Exactly where is that? How long would it take to get everything over there and get it back? These are complicated decisions. But let me see some nodding of the head. Isn't it true? Farmers have to make these decisions. So let's enable it with data and connectivity. All right, different farm. I will just pause here for a moment and let you become familiar with the Luna Dairy farm. That first one might have been in Illinois, Iowa, Indiana. This one is over in Pennsylvania, my earlier life. It's a robotic dairy. You can get familiar with it there. If Luna Dairy had good connectivity and really good AI systems and data pipelines, what could they do? The alfalfa growth model, using the near-term forecast for this week and historical trends from the past years, for the weeks that follow, it suggests that you commence your mowing on May 14th to get all of your acres harvested near optimally. Even though this may delay corn planting, we're 90% sure you can still complete corn planting in time to get enough growing degree days before silage. Right? So those of you that have farmed or you're familiar with farms, we tend to get very nervous about planting crops late. But there are ways to model these things and use data to maybe give some assurance that, well, a little late is not really that bad. I'm not at risk yet. Even though the neighbors planted, that doesn't mean that I have to. Maybe I can use data and models together to make better decisions. Your heifers should be moved from paddock 8 or 7 to 8 this afternoon. We could automatically open the gate and use some mini swarm UAVs to get them over there. But you might want to do it manually and check number 74 because her chewing behavior and her pasture roaming is a little bit atypical. But I suppose if we combine that with the first one from the first farm, well, the UAV can just take a little video and tell you, oh, she's fine. Water quality. Environmental temperatures have cooled significantly. Generally, a water intake lowers the temperature, but your water intake's unsteady by your cows, which indicates they're near their optimal comfort level. So that'd be comforting to know. Probably a little bit of nonsense because most of us only want to know the anomalies. When things are not right, please let me know. If everything's normal, don't keep telling me because that's keeping me too busy. Like if I only want to know when things are wrong, but I thought I would throw that in. Usually you rotate in your pasture system from paddock 3 to 10, but given the current soil moisture levels and the forecast and historical records, I'm 90% sure that if you go into paddock 8 first, you'll increase the feed production and gain 7% over the next 30 days. The environmental control, this has to do, I'll just let you read it. You're getting tired of hearing me read exactly what you can read. Are you getting some ideas of how improved data flow might improve the logistics and the strategic decisions that farmers and their advisors make? That's really what I wanted to instill today. Here's one related to livestock health. The My Feeder app says 8 calves are consuming milk replacer at below a threshold level that might have been set. 3 of those calves have already been treated for scours, but their activity and their thermal sensors are suggesting that the other 5 ought to be treated even before they have been treated. This is a little preventative, announcing prevention. And then one related to nutrients. All right, let's get that one. Third, farm. So, oh, there you go. I put this in here just for Robert and some others. And it's a great place out there in Monterey Bay. This is the Bluebird Gardens. It's a CSA. So there's your introduction to the farm. Just a reminder, this is what we call design fiction. But it also is a near-term vision of what could we and should we do. So your Arduino controlled temperature and humidity sensor are correctly conditioning the air within the greenhouse and based on the current tomato and pepper seedlings and onion sets profile within the greenhouse. So that's probably a message that wouldn't get sent because things are normal. Your transplanter instrumentation, probably an IsoBlue device from the Oat Center at Purdue, open source telematics unit is on your transplanter. And it suggests that you're seeding plants 12% higher than your target. You either need to dial that back or order more seedlings. And also it's a check. Did you really want to plant 12% more or not? Let's go back to that. The person operating the transplanter probably could see that. Maybe the person operating the transplanter is not the one that actually makes the decision. This is why you need connectivity to get it back to the person who actually does make those decisions. And what can the person in the transplanter or on the transplanter do with regard to ordering more seedlings? Well, they would need connectivity to do anything about it, for sure, because they are not at the seedling order desk. Right, soil monitoring. So I'll just let you know. How am I doing on time, Robert? Okay, just about right then, because I do have a couple more other than this. Okay, so this one. Check your chemicals in the washing station pre-treatment circuit because the pH seems to be off of it. The well water and the irrigation lines are normal, but that line is not normal. So it's a fusion of sensors across systems that helps you detect where is the problem. Not just that there's a problem, but there's a problem and it isn't there and it isn't there. That's really helpful. Think about how many times that would make your life easier, especially if you're dealing with, who was it? Aaron talking about his the wiring harness on a vehicle. Like it would be great if it would always say it's the green wire from here to there instead of something over here. This one sort of just social media related. And then the last one, with a better alignment of your supply to the demand over time, you could have a 22% increase in profit potential if you just did that a little better, looking at past data. So that's a little bit more strategic rather than tactical. I'll just have two more slides to cover with you. One is a bigger picture, opportunities for data and models. And I want to at least put this in your mind. This is my view of digital ag in the near term. It's not just data science. Give me a data set and I'll give you insight. It is some of that, yes. But it's data sets wrangled. It's what we now sometimes call biophysical models, but some of them are hydrologic, some of them are mechanistic or physical, some are biology, physiological. But if we can merge data and the summation of agricultural sciences over lifetimes, we know a lot about growing plants and feeding livestock. And some of that has been put to equations that are pretty good. They're not perfect. That's why we need data, but the equations are pretty good. And they're probably a little better than just only use of data, because data and artificial intelligence can send you down the wrong path sometimes. So let's merge data sets, things that I've collected in the past, data streams, like what is it currently right now, and then models together. That's where I see it. So let's talk about this one, which is, and maybe now you can think back to the earlier slides of those examples that I gave. Some of these are doing things that humans could do, but to do it much faster and more accurately. That's a good use of artificial intelligence, machine learning, deep learning. And the other category is actually doing things that you just can't do with the human brain. There's just too much to get your arm around. And so that's when we would use artificial intelligence, sort of two categories to lump those things. Boom, bada, boom. That's all, folks.
Perfect. I have one question that occurs to me. When you talked about all of this technology, how does that relate to meeting with government regulations? I actually very rarely hear that out here, but I know in California, probably the number one topic amongst agriculture folks is how do you meet government regulations and the reporting? And it seems to me that all this data that's collected is information that could meet government regulations, and perhaps you could get a third benefit perhaps in meeting the reporting requirements.
So there are conversations, and actually this came up in, so you mentioned this FCC task force on precision ag. Both Josh Seidemann and I on this group are also on that group. And that was one of the things that came up in the recommendations there, is to streamline some of those data sets so that you could just push a button and tell FSA those sorts of things. So yeah, there's a lot of room for improvement in this thing that we call interoperability to make data, still mine, but when I choose to share it, it would sure nice to be easy to just kind of push a button, go. And you know, it's like doing your taxes. The government doesn't need to know everything about your personal financial life. But we have, at least as a society, sort of agreed to that they need to know some things of it, and that's what makes it fair and balanced in terms of paying my taxes. I don't tell them everything. I analyze my personal story and I tell them what they need to know, and usually not much more than that.
Thanks to the previous speakers and to Robert for having me on. I'm going to bring kind of the reality of what we're dealing with day to day in this industry, and kind of try to tie up some of the things that the previous speakers talked about. We have two businesses, AgTech Insight and Growers Insight, and we focus on the last comment that Dennis was just making about how do you bring these things together. So just quick on my background, I grew up on my family's irrigation business out here in California. I've learned a lot, driven by farmers, driven by industry. I started selling technologies to farmers about 10, 11 years ago. In 2014, found myself at the first Silicon Valley AgTech conference, met all these weird people called VCs and startups, decided I needed to learn about that new world. I started AgTech Insight. Since then, I've traveled to Asia about 65 times. I've been to Latin America about a dozen times. I've been around Israel and Europe and all over the States, learning about what's happening in technology. And so, you know, it's really important to kind of take the ideas of where we want to be and where this industry is going and figure out how we turn those value propositions into business proposals and make business impacts for companies, because at the end of the day, we have to have someone pay for technologies and understand what the value is in them. So today, AgTech Insight, we have about 20 people around the globe. We cover all aspects of food and agriculture throughout the supply chain. And we do work with larger multinational companies. We do work with public organizations, NGOs, just kind of work across the ecosystem. We spun off a company called Growers Insight about a year and a half ago to help fix the problems that Dennis was just mentioning. You know, we have lots of systems out there. Each farming organization has a different system. Some of them are 20-year-old proprietary. Some of them are new, huge SAP implementations that didn't go right. I've never seen one that goes anywhere near and ends up where we thought it would be. And a lot of that comes from not having a good plan and understanding where you're going. So, you know, when we look at what we do with AgTech Insight, we provide consulting and advisory services to lots of different clients, but really we're creating ecosystems to bring the right technologies to work together, to help build plans, to help, you know, a traditional chemical business understand how they can leverage digital technologies, not only to grow their business, but through their, you know, kind of integrate it through their teams and help people, you know, a salesman that's been selling seed his whole career understand what the value is to be able to utilize these new digital technologies, both for himself and for the farmer or food company. Like I said, we have a team all over the world. We have lots of great people that cover different subjects. And this is a asset that we have on our website, on agtechinsight.com. It's an ecosystem map. It's hard to see here, but there's about 580 startups or companies, technology companies on the top. We have about 120 investors on the bottom, and then a handful of accelerators around the globe. If you go on our website, you can download this for free. You can also use an interactive version. So you're interested in finding a company that flies drones to collect imagery. You can click on any of the companies under that category, and it will take you directly to their website. So it's a really cool way to quickly and efficiently understand who's out there, what they're doing. I'm looking for smallholder solutions. I'm looking for soil or climate technologies, bee technologies, whatever. There's a lot of different stuff on there. So it's a great free resource. And we're gonna kind of supercharge this into a whole new format in the coming months. So lots of good stuff on the website. Like I said, the other company that we have is Growers Insight. And there we help build and implement 3 to 5 year technology plans for farmers. We work with a lot of larger institutional investors that have farm holdings all over the world, as well as large food companies. So again, my journey has been, hey, start in irrigation. Then I've been selling technologies, and I said, this stuff's great, but it's hard to find the value proposition. We're always learning. These technologies aren't where they need to be. And so, we've spent the last few years helping kind of move technologies to where they need to be today and where they're at. Now they're ready for prime time. But we have to bring them all together. So we look at ourselves as translators a lot of the time, to help a tech company, a government, different stakeholders understand what a farming operation really needs. And again, everything we do is data driven. So it's great to be able to collect thousands of data points across an organization and start to understand where the trends are on what the needs are and what the company culture is and what people are willing to do and able to do, and then roll all of that up into finding the low-hanging fruit. But you have to start with individual companies, individual people understanding, and then building from there, and then finding where the common areas are. You can't start from this big picture and try to narrow down. So I'm going to talk about workforce development. This is something that I have struggled with from day one in my businesses, still struggle with today. We work closely with UC Merced, and hopefully we'll be able to get some good things happening and through that organization. But in general, workforce, finding good people is next to it's probably the number one challenge for startups and scale-ups and scaling technologies today. These slides will be shared, but I wanted to just kind of share a little bit about the trends of what we're seeing in technologies. And there's a linear approach to this. So we first have to collect data, then we can put it together to build big data. Then we can start doing machine learning, and then we can start doing autonomous robots, AI, etc. But people want to jump straight to robotics and AI, even to machine learning. And I've dealt with lots of companies that come to California, say, oh, we're going to take all the data that you have and we're going to run it through our ML models. And then they find that we don't have the data available. We're collecting it on pen and paper. There's human errors involved. It's being input into Excel spreadsheets and then into old proprietary systems that can't push it out. And so we have this kind of process that we have to get through in order to be able to do the fun and exciting things. You can put a robot in the field, but if it doesn't know what a clod of dirt looks like and what it's looking for, what it's needing to do from the machine learning that you've taught it, from the big data, it's going to sit there and be a big dumb piece of metal that costs a lot of money and electronics that does nothing. So here's a lot of the technologies that we're seeing around the world being adopted. And again, you guys can jump into this. Pivot Bio just raised another like $400 and something million and are doing some really cool things with nitrate fixation. So anyways, there's some neat stuff happening. And it's really exciting to see where the industry is going. So, what's driving the shift, as everybody hears: environment, sustainability, social trends. You have, people like the millennial farmer with 350,000 followers. I have family in Croatia that follow the millennial farmer. They farm 500 acres in Croatia. So it's really neat to see how we as an industry can help tell people what we do and tell our story. There's more information available. We're seeing real-time pricing and visibility, especially in emerging markets in other parts of the world, where all you knew about what pricing before was what the guy that drove by on the motorcycle wanted to pay you or what your neighbor said you got paid. And so, that's where you see some really interesting trends internationally. TikTok is changing the face of every industry, everything that we do in our day-to-day lives, and it's going to keep happening. So things are changing, but how do we kind of bring all of this together? Myself, I wouldn't be in agriculture. I left my family's irrigation business for a few years and worked in real estate. And then I decided I didn't like people in real estate as much. They weren't as honest as farmers. So I said, I'll jump back into agriculture. But if it wasn't for going the technology route, I wouldn't be in agriculture anymore. So it's exciting. It's fun. You can make as much money almost or very close to it as you can working for a Google. I say all the time, 5 years ago, we needed more technology. Today, we need to know how to use it. We have everything we need for the next 5 years, but we do not know how to use it from a industry standpoint. We don't need more traditional programmers or engineers. We have plenty of those. We need translators. We need people that understand the basics of engineering and understand the basics of programming and development, but they know farming and they know the culture of farming. It's called agriculture because there's a culture built around it that is really hard for people to understand if all they know is an engineering lab and electronics or they know how to code. So where we don't necessarily, so traditional ag is set in their ways, and traditional technologists don't understand ag. So what we're trying to do here is taking the art of farming. It's in people's heads. It's watching farmers that go out to the field and taste the soil, play with the plants. They see things that more normal people can't. And so that's an art. How do we take that and transition it to the next generation? Because we have most of our workforce is in their 50s and 60s. How do we transfer it to the next generation? The younger generation doesn't want to do that. They want to sit on their couch. They want to lay in bed in the morning for the first 2 hours, see what's going on, get an idea of what needs to happen that day, and then go out to the field and start taking care of things. I'm 37, 38 years old. I'm right on the cusp of, I have partners and people I work with that are 35, 36. They work significantly different than me. I still have a lot of the older style of work ethic. I hate being on my mobile unless I have to. I will take my laptop out for 5 minutes of work where my partners will sit in bed or sit on the couch and work from their phone for hours, and I just can't handle it. So there's a transition here, but how do we take the information and the art of farming and move it into a data-driven science? So I have two different profiles I have been talking about for years and years. We've applied for grants over the years. We have not gotten a single penny for it. I've shared this information with dozens of different schools, different types of education programs through the years. This is from my experience in talking with thousands of startups, thousands of farmers around the world. There's two main types of people that we need in a workforce. One is what I call the director of ag innovation. This type of person, they will, if they're working in a food or farming organization, they'll manage kind of an integrated innovation team. Right now, the innovation team is like 1, 2, 3 people in a little room, in a little shed, in a little field. And they're just like the crazy people that like to play with stuff and bother us when we need stuff. And they're not integrated into these organizations because it's a challenge for them to kind of be able to work with and bring the value proposition and the business structure to the kind of the core of the farming organization. So we need to integrate these people into the farming operation, not be another silo to deal with. We need to kind of train, this type of person will train and translate what a sensor means or what this field means into the field operation. So they need to understand what a soil moisture sensor is telling them and need to be able to also speak Spanish if you're in a lot of the specialty crop side of things, and be able to understand and work with an irrigator, with a tractor driver, and help them realize what this sensor is telling them, what it means. Irrigators used to putting a shovel in the dirt, looking at what the plant looks like. And so to be able to correlate what 32% soil moisture means compared to putting a shovel in the ground and what that irrigator seeing, that's a translation. And so that's something that's really important for this person to do, to be able to translate that information. Then they need to be able to start building data-driven prescriptions. So taking the information, translating it, and then starting to build prescriptions. And there's platforms, there's machine learning built into them, there's AI that help do this. So saying, hey, based off of trends, based off of weather, based off of all these different things happening, this is how much irrigation you should put on. This is how much nutrition you need to put on. This is when your optimal harvest time is. There's technologies that can do it, but you have to train them, and the technologies need to be trained. And so if you don't have this translator, the irrigator probably doesn't understand how to train the technology. But if you have someone that can help kind of bring the parties together, now you can start doing prescriptions, and every week, hey, keep doing the irrigation prescription, or the irrigation scheduling the way that you have. But as a technology person, I'm going to give you my prescriptions. Once they start seeing, hey, your prescriptions are right on, they're better. Now people start buying into it. They understand it, and they can adopt it. So, we need people to teach machines. And when you listen to futurists, I don't care what technology or what industry they're talking about, futurists are talking about what people are doing in the next 5 and 10 years from now. It's not programming, because it's all becoming no code, low code. It is teaching machines. It's teaching other people how to teach machines as well. So they also have to understand business. You have to be able to bring these dispersed large data sets together into BI tools and be able to present that data to leadership. And that's a core of what we do with Growers Insight, is we take these dozens of different data sets, we pull them in through Microsoft tools into Power BI or some of the other BI tools, and we pull all these different data sets together to put them into a format that a business owner understands, and it can help them make better business decisions. Because right now 95% of the decisions are still being made in your head. Even if they have all of the technology out there, they are still making the decisions in their head. So they have to understand the business side. When you're talking about so I've been talking about how this position would work in a farming organization. It goes almost carbon copy if you're working in with a startup. So you're a salesperson for a startup, you're a customer success person for a startup, and you're able to, you need to understand all of this and be able to bring this value to your customers. So here's the skill sets that the workforce needs. I'm running out of time because that seems to happen. But I'll just run through real quick. They need to really understand farming. They need to have leadership and cultural skills. They need to understand the basics around programming and mapping. They need to understand data structure, but they don't need to, have a 4-year degree and be able to program stuff on a day-to-day basis. They need to think like leaders, because these people are going to, we become the right-hand man to leadership, or right-hand people to leadership in these farming organizations, because we have the information. We can answer the questions that nobody else can. So they need to think like leaders. They need to have sales and growth skills. They need to have entrepreneurial mindset, because you constantly have to be thinking about, how do we do stuff better? How do we help people around us? And how do we, you have to have great people skills as well. So that's kind of one type of person. And the other type of person is what I call a field support or operator type of person. So this is kind of the second profile of what the industry needs. In a farming or food organization, they will work individually or on a team. These are going to be the people that are installing, maintaining, and supporting technologies. They're going to be installing soil moisture sensors. They're going to be installing plant sensors. They're going to be helping fly drones, helping get robotics started. It's a ways out to be to the point that a robot's going to fix another robot. So we need people that can get things started, that can teach them, and they can kind of relay what's happening on the ground to that next level of management, technology management person I spoke about before. They need, again, basic programming, data, troubleshooting skills. They need to be mechanically inclined. They need to be able to weld. So when something breaks on their robot, they can weld it. They need to be able to, dig a hole, because you still have to dig holes. You still have to play with dirt. They have to be able to program. They have to be able to write basic lines of code or understand that data structure. And they need to be able to train other people as well as technologies to do this. They also need to have some basic business skills to ensure that their tech is providing value so they can continuously get more funding and keep building what they're doing. Same thing in a startup. They're going to be doing installation training, support, etc. For farmers and food companies. So these are the two kind of profiles of people that we see that are needed throughout the industry. I don't care what part of the world, what part of technology you're talking about. These are the people that are needed. So when again, we're talking about this installation support person, they need to have robust farming knowledge as well. You need to understand that a tractor is going to come through, whether it's robotic or not. It's going to catch loose wires. It's going to run into things. And how do you kind of mitigate that? They need to be a skilled tradesperson. They need to be able to turn wrenches. They need to be able to weld. They need to be able to also be able to do soldering and read schematics and understand basic electronics. Again, I'm not saying they need 4 semesters of this. I'm saying they just need a basic understanding, because going back to what Dennis finished on, you can't teach someone everything that they're going to need to know for a specific technology. So give them a basic understanding, and then let the company that they're working for teach them the real specifics. They need to have a team attitude. They need to work with the culture, old, young, Latino, otherwise everybody needs to come together and work together with this. It can't be, hey, that crazy tech guy, or that irrigator doesn't understand. So it needs to all come together. They need to have great people skills, basic programming, and again, they need to understand some pieces of the business side of it as well. Anyways, that's myself. We have a lot of information on AgTech Insight's website, as well as Growers Insight. I like what our group is doing here. I think right now the industry is at a point that things are moving, things are changing, and we have lots of opportunities moving ahead. In the US, we are falling behind. I get better signal when I'm in Latin America or Asia than I do driving around the Midwest. So broadband is absolutely an issue. But we also have to look at, again, you can lead a horse to water, you can have all these things available, but we need to have translators out there. We need to have processes. We need to help be able to accelerate the usage and adoption of these technologies. So thank you again for your time, and looking forward to our discussions here as we jump into round robin, you could call it. So thanks a lot.
Aaron. Since you talked about all the different skill needs for agriculture now, and you've already mentioned that you alluded to a traditional university education doesn't necessarily meet that. So do you have a suggestion of how, and I'll also ask our panelists, since we have 2 people from universities. So what kind of education do you think is needed for the workforce, and granted, that's a very diverse type of skills that would be directly functional from what you're seeing on the industry side?
Yeah, so from my standpoint, I have a different background. I was homeschooled from fourth grade through high school. I did a couple of years of junior college. I have one class left to get my AA. It never meant anything to me. So I look at schooling quite a bit different than other people. Lots of people think I have masters or doctorates and things, and I don't. I have, as my parents say, multiple doctorates from the real world. I've learned a lot of things the hard way through the years. But I think the answer is, we have to start earlier. I think in high school, people need to take some more business, they need to learn a bit about business. We need to have more farm mechanics. We need to have some programming. I think some of that stuff can be done in high school. The rest of it, again, I think that it can be done in a 2-year or 4-year type of situation. We're always going to need more academics. I'm talking about the usage of the technologies that we have today, not necessarily about building the new next greatest things. We need to use what we have available today. So if we're talking about workforce development for supporting these technologies, I think it can be done in a lot of different ways, but to take 7 or 8 business classes or even 4 or 5 isn't going to make sense for this type of position. I know people that are in that support role where they're installing and supporting things, and they're making $160,000, $70,000 a year, full benefits, etc. So they're making really good money, and they don't have, some of them don't even have high school degrees. So it's in the industry, it's not about the degree, it's about the understanding and the experience. So to me, it's the junior colleges are the ones that should really be jumping on this. But junior colleges seem to want to push people into 4-year colleges rather than kind of helping them build into the workforce.
Yeah, my one comment here is,
we have really downplayed the importance of community colleges and junior colleges. We have somehow valorized the 4-year degree as anything else being a failure. And going to what Aaron was saying, I think that we really need to reinvest in our junior colleges and our community colleges. So that's just my point. Not everyone needs a 4-year degree.
I got really excited when I saw Aaron's slides, because we got to see him a day or 2 ago, because so much of the realm that I work in this intersection of ag and electrical and computer engineering, systems management, my dream graduate that we would generate is that. Now, I'm not saying that we turn out enough of those, because we don't, but I think there are academic programs that are that. But the challenge is sort of this. We want somebody, like he said, who can weld, who doesn't mind working hard and digging a hole if they have to, but can write code, understands electronics, and that list goes on a little bit longer. And I fully agree about the role of community colleges and 2-year degrees and other technical programs. However, much of that has a prerequisite stack. And it's not that you would need to necessarily take university courses, but the individual who does that has to be so motivated and passionate. It's a little bit like graduate student researchers, yeah, everybody could in theory do it, but you've got to be, on it with an attitude. And to do this kind of work, because it is so diverse in those categories, it takes just the passionate, motivated person, whether they learn it on YouTube or just by doing it and failing or taking classes. It really is sort of a different person than traditionally we would have generated out of educational programs.
And a bridge that I've seen and we've written grants for again, and I had before COVID, we were in super deep discussions with the ex-secretary of agriculture and a number of others, is to build these internship in a box programs, we call it. So, it's hard because you have an intern that goes out and shows up at a farmer's operation. They go, okay, yeah, great. Go take some samples, go do this and that. Well, if you build a, kind of give them that base work and then build a program for, you're going to show up to the farming organization and this is what you're going to do. You're not going to wait for them to tell you what they want. You're going to go to them saying, this is what we're going to do. We're going to kind of work in the back and pull all these data sets together, start playing with things, get to know your people, and start seeing like how these, how we can come into your organization and help you utilize these different technologies that you already have. That's a platform that's not very hard to put together. You can run groups of 20 people, 20 students at a time through it, and they're going to different organizations. But that's a way that we've talked about kind of bridging that gap of kind of between those two dispersed areas. Being in agriculture, we haven't thought about cybersecurity. I know 4 very large organizations that have been attacked in the last year. COVID spiked it like crazy, and including JBS, which probably everybody heard about. So all of a sudden, now what happens if someone taps into Taylor Farms processing facility and turns the chlorine off on their lettuce processing, and it allows it allows an E. coli or something to go through. So there's things that we haven't had to think about in agriculture because we've been on the back burner. But a company like Grimway was purchased by a big investment firm, and 6 weeks later they had a huge cybersecurity attack. And so these things are happening. It's something, and when you talk about IoT, we have no security on most of the IoT out there in the field. And so if you start thinking about how these things can affect what's going on in today's world, it's absolutely something that's important to build into your plan. And so it's a main piece of what we build into our plans when we're working with farming organizations. Not only that, but having a backup, because they'll do ransomware, right, is what most of these guys are doing. So, there's companies that it took them 2 months just to get their email back up. And so that now the supply chain stops everything. And so you have to have an instant backup to be able to switch over to.
You talked a lot about what is needed. I'm wondering, and then we talked about how we need to sort of encourage people to also go into like associate degree programs. But I'm also thinking about reskilling. I think one aspect is skilling, but then the other is reskilling as well. And like you mentioned, we need people who can code, who understand electronics. That gives me an impression if someone knows how to code, they would go to the Silicon Valley. So how do we align incentive structures to encourage people to stay? So I'm just curious if you're doing some work around that. So that's one question. Actually, that's about it.
Very short response to that question. And it's not an answer to the question. These things that you bring up are great prompts. And in this case in particular, that should steer the next generation of what is cooperative extension in the United States. Yeah. It is the ongoing development of people who are out there to keep them up to date with the latest in tech. That is our charge.
And I was in 4-H I did 9-10 years in 4-H. And so that's where I go back to, in high school, let's use social media. People are spending too much time on TikTok and all these other things. So let's use social media to help people realize that agriculture isn't just digging holes and hard work and long days. It's fun, exciting, it's sexy. There's things that are happening. And so so that's why we do a lot of work with UC Merced. It's like 78% is first time college people. They're from the Central Valley, and we want to keep them in the Central Valley. And so do you need to go to Silicon Valley? There's a mass exodus out of Silicon Valley right now from COVID. And so I think it's going to open up the opportunities, but it has to start with us as an industry telling people coming up in the industry, trying to figure out what they want to do. This is something you can do. This is what it looks like. It's fun, exciting. You can make really good money at it. And you're not going to be stuck flipping burgers with a 4-year degree. You're going to be doing something that you enjoy. And the other thing I think is that we push really hard on sustainability because the younger generation seems to care a lot about sustainability. So you're helping the earth, you're flying drones, you're making people's lives better. So anyways, lots of opportunities.
One of the points that you actually before we started on this panel, as part of the discussion, is that we have to cut through all the different silos that we work in. We have to cut across all of that. And that's part of the challenge. The point of this panel was to bring in 3 people who work in different areas. So in one spot, you could hear a perspective. And I put this up, but I just called it the triple helix on ag technology, worker skills, and broadband. And actually, thanks to this discussion, it was raised. I think we ought to be the quadruple helix, and we should add cybersecurity because that is an important point. And I think of it as something in the backdrop of should be an inherent part, but it's very clear. It probably needs to be on the front of things and be integrated into protecting those resources, because we have a whole infrastructure that is very vulnerable to cybersecurity threats because it was developed before cyber was a reality that's there. So, but we have the opportunity, since this is new technology, to get it baked in to the process. So, and I will say, and it's probably appropriate that we're at the Convergence Center and we're talking about cross disciplines. So thank you to the panel, 2 here and 1 remotely. The technology worked.